Okay, so we've already gone through this. Hey, if something pops up and you want to talk about it, we can talk about it. So the algebraic thinking, there are three main strands, and we've done examples of those. In the shape times shape, we're looking at structures within the numbering systems. That's so just looking at the numbers and seeing how they work out with each other, especially with those respecting to arithmetic. Study of patterns, when we looked at the V pattern, relationships, functions, and when we get into relations and functions, that comes later on. That comes sixth, seventh, eighth grade, pre-algebra, algebra 1, and stuff like that. Now, a lot of times with these two can connect because you can look at numbering systems and stuff and come up with these patterns. And then, of course, mathematical modeling is what we did with the comparing quantities. Again, we did that by looking at some structures of the mathematics of the numbers. So all three of these strands are interrelated. And we don't take one after the other. We don't take one and then one separately and another one. We want to tie them together. We want to see how those things tie into each other. So properties of operations. There's a whole bunch of times. A lot of times we just try to have students memorize it. Like, what's the commutative property for addition? Well, that's move. So that means that is the A plus B is the same as B plus A. The associative property for addition is, so if we take three numbers, by the way, addition can only do two numbers at a time. So we can add A and B first, then C. Or we can add B and C first, then add to A. Those are the same thing. Now, in terms of multiplication, it's the same thing looking different. So that's 3 times 4 is the same as 4 times 3. And the same thing if we take the product of two numbers first, and then multiply to a third. If we multiply the second two numbers first, and then the third, it's the same thing. Now, a lot of times these are good, especially in combination. For example, in the something like if we have the example of let's go 7 times 5 times 4. Now, look, if we just go straight left to right, 35 times 4, now we're sitting thinking about it. But wait a minute. That would be this. But if we use the associative property and we go 7 times and do 5 times 4 first, now we're looking at, wait, 20. 20 times 7. That's quick. By the way, the one I should have kept in here, but I didn't include, but we've seen multiple times before, especially when we're looking at multiplication, is the distributive property. Now, and this is really computer writing there. So when we take and we distribute multiplication across addition. So A times B plus A times C. Now it doesn't matter if we put the A in the first or in front or behind, it's the same thing. By the way, we can still have the distributive property for division where we distribute division across. I'm not going to bother writing it down, but it's something we've seen before. You don't use it sometimes, but not that much. Actually, that would be breaking up the dividend, what we're dividing by. Okay? Now, if we really want to take a look at it and say, what about with the 2-digit times a 2-digit number? We do more than just one thing, don't we? Well, that's like the distributive property twice. Or I call it double distribute. So some things you can do in terms of thinking of algebra and thinking of some of the strands, especially with the number strands. Number strand is some things like always, sometimes, or never. And true. So is this sentence, the sum of two consecutive numbers is odd? Is that always going to be true? Sometimes going to be true? Or never true? Okay? So now, and then we want to try to have the students explain it. Explain your answer. Explain your answer. So hit pause. Now come back. Okay, so two consecutive numbers. So in two consecutive numbers, we always have an odd, that was nice, and an even number. So an odd number is always just an even in the consecutive ones, let's say +1, and then this other even number. Well, anytime you add two of the same numbers, that's going to be even, because remember the definition for even means 2 is a factor, or it's something times 2. So we would have 2 times that even +1, and this +1 here, this one here, makes that odd. Okay, another one. Again, think about it. Oops, let me go back. I forgot to answer the question here. So that is always true. Boy, a lot of jumping today, and this tip, I might confuse her at home. So over here, 1/4 is 1/2 is larger than 1/4. Pause. Welcome back. Can it be true? Can it be true? Oh, of course it can be true. Yeah, 1/2 is larger than a 1/4. Does it always have to be true? No. That's why this is sometimes true. Wait, how is not 1/2 larger than 1/4? Consider the whole. What is the whole? So a counterexample. This is something you might have seen, you might have remembered from geometry aspect, but we can still use it here when we're coming up with generalities. So 1/2 of an inch is definitely not larger than 1/4 of a mile. So because we're vague at what's the whole, that's why it's sometimes true. Now, if you say 1/2 of a whole is larger than 1/4 of the same whole, same unit, you got it. Okay, symbols. A lot of times we talk about what's an equal sign. Well, an operational view for an equal sign is do something. That's when we have something like 3 plus 4, and you say is 7 or makes 7. By the way, always running it that way, and using that language can cause issues. Relationships, relational view. So operational view, that's what we just talked about a little bit. So when we sit, or one of these questions, like the 3 plus 4 is what plus 5? Or something like the relationships between, if we know 3 plus 4 is the same as 7, then 7 minus 3 would be the same value as 4. So these structural views sometimes is some numerical relationships. That's where your properties will fall in. Now, inequalities, what's the difference between an equal and inequality other than greater than or less than? is the relational view, because we really don't do anything with those. By the way, I know that alligator and stuff works, but you always want to think about what happens when later. So talk about your greater than and then this would be your less than. Okay, again, this side is less than this side. This side is the right, left is greater than the right. So as you're reading it, you're going from a larger value to a smaller value. A smaller getting checked out to a larger value. Okay? And again, when we want to try to conceptualize, what do we mean by equality if we use the idea that 3 plus 4 makes 7? Can lead us to some issues. What we want to think of that as a balance, though. The value of 3 plus 4 is the same value, is the same as 7. And then we could use true-false sentences in the same manner. Are those two the same? So like here, we wanted to put 3 here. Are those the same? No. That would be a false, and then that helps us leading to solving equations. And in algebra, which we can see before, using some number combinations. So wait, hit pause and go ahead and answer these questions. So one thing I like to do, one thing we could do with this one is set up a table. And you can do it horizontally or vertically. I like the reason I'm doing horizontally this time, space. So the dies are from 1 to 6. So we want the sum of two faces. So if the red is 1, white has to be 6. 2, 5, 3. Now what I'm doing is counting along the red one and letting the white, the other die, come about. Or just match up, then 4, 3. And then 5, 2, and the last die. Last option is if red was 1 and the white is 6. So those are all the different possibilities. Now, change it just a little bit. Now this would be something, or if I wanted to challenge my students, a student goes, boom, got it done, okay, whatever, oh, this is no problem, this is easy, show me something hard. Give that student, ask this question: what are the possibilities if you can't tell the difference in two die? That's something to think about. I'll let you think about that. So again, what do we end up getting to? Variables. What about variables? Well, unknown values. So when we use some kind of quote x plus 3, well, 3 more than some unknown value is the same value, is going to be 7. Now, for that, there's only one possibility. Not that there's one possibility. There's one possibility to make the equation true, to make left and right side to be equal, to be the same value. How about any value you want here? Just doesn't make it a true statement. Simplifying expressions, so if you got a whole bunch of them, narrow it down, make it easier to see. Simplify. And then use quantities that vary. This really helps out a lot when we're looking at proportions and proportional thinking. That wraps up the rest of that. And then I am going to go ahead and show the common challenges and misconceptions on a different video. Okay.